Okay guys, so for today's video you're going to need a couple of things. Our notes are page 33. Our worksheet is page 35 and it looks like this, mole to mole and mass to mass. I'm also going to want a periodic table and I'm going to need a calculator. Now as I take these notes, I'm going to be using lots of different colors so that you can kind of tell where the numbers are coming from. If you want to use colored markers or highlighters or pins to kind of keep track of things, that might be helpful for you. So here's what we're going to be talking about today. We're going to be talking about something called stoichiometry. Now, stoichiometry is a big fancy science term that's basically changing from one unit to another within a chemical reaction. So what we're going to be trying to figure out is how do we determine how much stuff to mix, or how much stuff will form. So all of the calculations that we've been doing up until this point, mole to gram or gram to moles or moles to atoms, all of those calculations were so that we could work our way up to stoichiometry. Because stoichiometry is what we actually are trying to do. We're trying to figure out how much of my reactants I should measure out if I need a certain amount of products, or how much products I'll make if I have a certain amount of reactants. And this is one of the most useful skills as a chemist I can have. Now first we're going to start with something new. We're going to look at mole to mole conversions. Now anytime we ever do stoichiometry, I'm going to need a balanced chemical reaction. Okay, so here's my balanced chemical reaction. I've got 2 C8H18 plus 25 oxygen, and I'm making 16 carbon dioxides and 18 waters. So we spent a lot of time learning how to balance our chemical reactions. And it turns out that we still need to be able to balance these because this is what we're going to use to figure out how much stuff to mix. Now we spent all of this time figuring out our coefficients, our numbers in front. These numbers in front tell us how much stuff we need to mix in terms of moles. So what it's telling me is that if I mix 2 moles of C8H18 with 25 moles of oxygen, I'm going to make 16 moles of CO2 and 18 moles of water. So these numbers out in front are telling me the number of moles. And this is my chemical recipe. This tells me how things relate to each other. So it's going to allow me to change from one reactant to another. Okay? So here's how this works. We're going to talk about something called a mole ratio. Okay? So when we talk about a mole ratio, we're looking at the numbers in front. So I could say something like, I need 2 moles of C8H18 for every 25 moles of oxygen. I could say something like, for every 2 moles of C8H18, I'm going to make 16 moles of CO2. So here I've got a 2 to 25 mole ratio. Here I've got a 2 to 16 mole ratio. Okay, so here's how we use our mole ratio. I've got my example. So if we have 4.2 moles of C8H18, how many moles of O2 need to react? Okay? Now, just like we've done before, I always start with my number given. So my number given in this problem is 4.2 moles of C8H18. So just like before, because I'm starting with moles of C8H18, they have to go on the bottom. Okay, here's where it gets different. What I'm changing to still goes on top. I'm changing to moles, but this time it's a completely different element or compound. Now, anytime I'm changing from one element or compound to a completely different element or compound, I get this information from my recipe. So I look at my balanced chemical equation and I look at the numbers in front. So the number in front of O2 is 25. So I put the 25 here. And I'm going to go ahead and just put it in a purple box, since it was in a purple box up here, just so that I remember where it came from. Okay? And then moles of C8H18, the number here had a 2 next to it, so I'm going to put a 2 there. And I'll just go ahead and put a purple box around it. Now it's exactly like we did before. Anything on top we multiply, anything on bottom we divide. So 4.2 times 25 divided by 2, and I get 53, because I can only keep 2 sig figs, moles of oxygen. Okay, so let's go ahead and try another one. Okay, what if we need to make 8.2 moles of CO2? And I want to find out how many moles of C8H18 you need to start with. Okay, so, oh, that should have a do. Do we need. So again, I always start with my number given. So this time, I've got 8.2 moles of CO2. I'm going to draw my time sign. I'm going to draw my line. Moles of CO2 go on the bottom. Moles of C8H18 go on top. Okay, remember, whatever I start with goes on the bottom. Whatever I'm changing to goes on top. Whenever I change from one element or compound to another element or compound, I have to look at the chemical reaction to see how they're related. So moles of C8H18. I look up here. I had 2 of them. So I put my 2 here. I'm going to go ahead and put it in a purple box because it was in a purple box up there, so I remember where it came from. Okay. CO2 is on the bottom. Again, I look at my chemical reaction. I had 16 moles of CO2. So when I plug this into my calculator, 8.2 moles times 2 divided by 16, I'm rounding my answer to 2 sig figs, so I should get 1.0, because I need 2 sig figs, moles of C8H18. So in this case, if I wanted to make 8.2 moles, I need to start with 1 mole of C8H18. Okay? So that's what we're going to be doing on page 35. Okay? So if we look, there we go. Problems 1, 2, and 3 are all mole to mole conversions. Okay? So first, I need my balanced chemical equation. I've got 3 C's here, 1 C there, so let's multiply that by 3. I've got 8 H's here, 2 H's there, so let's multiply that by 4. 4 times 2 is 8. Now let's look at our O's. 3 times 2, I've got 6 O's there. I've got 4 times 1, so I've got 4 O's there. And because they're separated by a plus sign, I add them, so 6 plus 4 is 10. I know those don't look like O's, those look like zeros. You may want to write yourself a note. So, since this is 10, I've only got 2 there, let's multiply that by 5. Now, because I don't have a coefficient here, I know that that coefficient is equal to 1. You don't need to write it, but just in case, I'm going to write it here to make my life easier because I know I'm going to be using these numbers in a second. Okay? So, how many moles of oxygen are needed to react with 4.3 moles of C3H8? Just like before, I start with my number given. I draw my time sign, I draw my line. I'm starting with moles. Moles need to go on the bottom. Okay? I'm changing to moles of oxygen. Now remember, anytime I'm changing from one element or a compound to another, I need to get those numbers from my equation. So I go back to my equation for O2. The number next to O2 is a 5. Okay, so I'm going to put a 5 there. The number next to C3H8 was either blank or a 1. So I'm just going to put my 1 there. Okay. So plug this into my calculator. 4.3 times 5. I get 21.5 moles of O2 Remember, I can only keep 2 sig figs. 1, 2. That'll round up. So I've got 22 moles of oxygen. So take a second, solve problem 2 and solve problem 3. Remember, you're getting your information from the equation up here. So number 2, I'm changing from C3H8 to CO2. Number 3, I'm changing from C3H8, this time my number in front changes, to H2O. Okay?